OK, so let's go to good old Desmos and see what I got here. All right, so again, we're just looking for some common characteristics. Got it? Common characteristics. Don't need to raise your hand yet. Just want you guys to look at it. OK. Interesting. Again, these are functions and their inverse. Interesting. OK, so now comes into the point, does anybody maybe recognize maybe some things that they kind of see like some commonalities? Some fresh ones. Yes? Line y equals x. Do you remember the name of that function? No? It's one of your 12 basic trigonometric 12 basic functions. It's the identity function, the y equals x, right? And whatever x is, that's what y is, right? So let's just see if that kind of makes sense. Does that look like that's a line of symmetry? Right? Yeah, very good. Now, real quick, does that tell us if it's, does that mean these are even or odd? No. Even functions, right, are symmetrical about the y-axis. Odd functions are symmetrical about the origin. So don't confuse symmetry about y equals x as a test for even and odd, right? They do have symmetry about the y equals x line. Very good. Does anybody notice anything else? I actually have that programmed. Anybody notice anything else? You guys want a little hint? Does anybody recognize anything else? Anything else? Yeah? Flipped. What else could you say? Flipped, swapped, right? Switched, right? But you guys see how the blue has the x, y, and then for the red, it's the exact opposite, right? They're opposites of each other. They're flipped. They're swapped, right? Now, that's very important because we have some things that are related to x and y coordinates. For instance, domain and range. Look at the domain of that blue graph. The domain of that blue graph is all numbers greater than or equal to 2. What is the range of the red graph? All numbers greater than or equal to 2. The domain of the blue graph is the range of the red graph, right? And also, the range of the blue graph is all numbers greater than or equal to 0, where the domain of the red graph is all numbers greater than or equal to 0. So notice how, since the x and y coordinates are kind of swapped, that means the domain and ranges are swapped, right? So these are functions. One is a function, the other one is the inverse. But you guys can see this relationship. And it works for all of them. You know, these don't have the same point. But you guys can see all these different functions and their inverse. Now, let's go and look at example number 4 and see if you guys can figure out what's the difference then with number 4. So one of the function, so maybe this is a little too much. Let's just do this. Here is a function and its inverse. How is this one different than the other examples? Yep.
The other ones were reflecting over y equals x, but this one is either reflecting over the y-axis or the x-axis.
Well, I mean, here's the y equals x line. So now you can see the y equals x line. Does it look like it's a reflection about the y equals x line? Yeah, so it probably does look like more of it's like an easier like a rotation though compared to like the other ones. I'd definitely agree. I can see like definitely where you see that. But this is a function and this is a representation of a function and its inverse, kind of. There's an issue though with it, or another issue that I'm thinking of. Not so much as far as the reflection. Oh, is that an issue? I mean, this is the chapter on functions, right? So don't you guys think it'd probably be a good idea to keep things with functions, right? Or if I said, hey, here's a function and its inverse. Here's the black graph. Here's the black equation. You'd say, well, that's not even a function, so why are we finding the inverse of it? Correct? Right? I mean, this is the study of functions. So yeah, exactly. If you try to find the inverse of that, you don't have a function. Or if I said, hey, here's a function, find its inverse, you say, that's not even a function. So why are we trying to find the inverse of it? Correct? So we're in functions. We're going to study functions. So here comes the big question. What could we do then? Because this is the problem we're going to work on. What could we do? Or what have we learned maybe in this class that we could do? Maybe like restrict some things? Could we possibly restrict? Let's pretend purple is our function graph. Okay? Could we restrict that domain? Let's look at it. What if we restrict the purple graph to only positive values? Then we reflect that. So do you guys see how? Let's change this. Sorry. Not that one. There we go. So remember, it's purple and black graph, right? Look at how, what if I only take the green portion of the purple graph? So instead of using the whole purple graph, I only use the right-hand side. That means I'm going to restrict the domain to only positive numbers. So now when I reflect that about the y equals x line, I only produce this portion of the graph. Isn't that now a function? Yeah. So when we're trying to find the inverse of something and we can't figure it out, we can always restrict the domain. And that's something we'll talk about, obviously, as we get into our formal definitions. But we're going to be using domain restrictions in this class, kind of like what we did for piecewise functions. All right? So that was the presentation there. All right, so let's go ahead and talk about then our inverse functions and our general notes of inverse functions.